3. Simple harmonic motion. Simple harmonic motion is a pattern of motion in which an object goes back and forth repeating the same track. The simple harmonic motion is a motion that has a constant period of completed circle and has a constant width of motion. Quantities in relation to simple harmonic motion are as follows. 1. Time, which the object moves past, is the time that the object moves from the beginning spot. The time continually increases. 2. Period of completed circle is the time that the object uses to come back to the original position. It is a fixed amount. Every round uses the same time. Moreover, a period of completed circle can be calculated from the frequency of the motion as follows. 2. Angular velocity. Angular velocity is velocity that is compared with the motion which is a completed circle. 3. Position of an object. To locate the position of an object, we use a symmetry point, or the middle point of the motion, as a reference point. The reference point is indicated by coding X or Y depending on the pattern of the motion. It is divided into harmonic on the x-axis and harmonic on the y-axis. In this case, we will refer to the harmonic on the x-axis, where the amount of x can be positive or negative. The greatest amount on the right and the left which is equaled is called amplitude of the motion. To find the position at a particular time, it is done by finding a relation of a circular motion on a shadow of the object on x-axis which moves in a simple harmonic motion. Example 15. An object moving with simple harmonic motion has a 2-meter amplitude and a frequency of 1.5 Hz. Find the position of the object at the 7th second. The position of the object is 2 meters on the left. Example 16. From the graph, find amplitude and the motion's equation. Amplitude equals 3 meters. The motion's equation is x equals 3 cos pi over 8. 4. Velocity of an object. To find the velocity of an object, it is done the same as finding the position. The velocity of an object, which moves with simple harmonic motion, is the velocity of a circle on x-axis. Example 17. A clock pendulum swings with the angular velocity of 5 radians per second and has amplitude of 4 meters. Find the velocity at the 1.1 second. The velocity is 14.14 meters per second to the right. 5. Acceleration of an object. To find acceleration at a particular second, it is done by finding centripetal acceleration of the circle. The acceleration of simple harmonic motion is equal to the centripetal acceleration on the x-axis. Example 18. An object moves with simple harmonic motion. It has a frequency of 2.1 Hz and an amplitude of 50 centimeters. How much is the highest acceleration? The highest acceleration is 87.12 meters per second squared. Example 19. An object on a spring bounces in a simple harmonic motion with the angular velocity of 8 radians per second, at the point which x is 0.25 meters. How much is the acceleration of the object? The acceleration of the object is 16 meters per second squared. The bouncing of an object on a spring. When an object is attached to a spring and the spring is pulled or pushed, then let go, the spring will bounce back and forth. It is a simple harmonic motion. For the bouncing of an object on a spring, the distance that the spring is stretched the first time is the amplitude of the bouncing. The frequency of the bounce is considered from the force which the spring exerts on the object. Example 20. An object of 2 kilograms mass is attached to a spring with a fixed amount of 800 newtons per meter. When the object is pulled, the spring is stretched for 50 centimeters and then let go. How much is the frequency of the bouncing and the highest velocity of the object? The object bounces with the frequency of 3.18 Hertz. The highest velocity is 10 meters per second. The swing of pendulum. The swing of pendulum, which is back and forth on the same track, is considered a type of simple harmonic motion. Finding period and frequency of swinging. Whereas t is the period of the swinging of pendulum, lambda is the length of pendulum's rope. G is gravity acceleration. Example 21. An object is tied with a rope which is 40 centimeters long. Then, the object is left to swing. Find the frequency of the object's swinging. Conclusion. 1. Characters of projectile motion. 1.1. Velocity of the object. Number 1. Horizontal velocity is the same amount at every point. Number 2. Vertical velocity is calculated as free falling. 1.2. Equations of the motion. 2. Characters of circular motion. Linear velocity, angular velocity, centripetal acceleration, centripetal force. 3. Characters of simple harmonic motion. 1.1. Position of an object. 1.2. Velocity of an object. 1.3. Acceleration of an object. 1.4. The bouncing of an object on a spring. 1.5. The swing of pendulum.